So that will, all right. So we'll be answering the questions as we go along, or at the end of there. Put your questions in the chat. If you're not aware, this is MNBI. We're just finished up our 501(c)(3) membership. We are open for looking for new members and going across there. So please, we'll be putting the link into our website in there, and feel free to join Char Talk or join Minnesota Biochar Initiative as a supporter of Char Talk and the additional efforts that we have. But today's speakers, I want to introduce. First of all, we have Timothy Broderick, who is a seasoned market access and business development leader from Joliet, Illinois, with more than 2 decades of experience advancing healthcare technology and data-driven solutions across complex regulated environments. His career includes national leadership roles spanning hospitals, healthcare systems, specialty pharmacy diagnostics, and digital health, where he's consistently built scalable go-to-market strategies, secured high-impact partnerships, and negotiated multi-million-dollar agreements. Timothy's work is increasingly intersects with climate-smart and bio-based technologies, including his collaborations with IEC Thermo, who is presenting this event, a leading provider of industrial drying and thermal processing systems. Through this work, he has gained firsthand experience into the biomass processing, carbon negative technologies, and the operational realities of scaling biochar-related solutions. Beyond his technical and commercial leadership, Tim is deeply involved in community service, sustainability, and public engagement. Serving on multiple boards and advisory groups throughout the greater Chicago region, his interest in biochar reflects his greater dedication or broader dedication to practical science-based solutions that strengthen environmental resilience and support healthier communities. As a speaker for MNBI's Char Talk series today, Tim brings a unique blend of operational experience, strategic insight, and real-world experiences, translating complex systems into accessible, actionable knowledge for diverse audiences. And also speaking today is Walter J. Hawkins, a chemical engineer and process technology executive with nearly 4 decades of experience commercializing industrial thermal processing and environmental solutions. As president and senior chemical engineer of Innovative Environmental Companies, IEC, since 2007, he has led the development of a broad portfolio of high-performance specialty products, including high surface area absorbents, acid alkali neutralizing media, hydrophobic materials for oil-water separation, disinfecting absorbents for medical applications, and environmentally friendly firefighting and fire retardant chemicals. He has designed and installed the manufacturing infrastructure required to produce these products at scale and built the corresponding sales network to support commercial adoption across industrial markets. Mr. Hawkins is widely recognized for his applied engineering leadership in drying, calcining, and solids processing systems, expertise directly related to biochar production and downstream handling. Over his career, he has designed and commercialized novel flash dryer calciner systems, highly flexible fluid bed dryer configurations, combination fluid bed flash dryer concepts, and a patented multi-phase drying system for temperature-sensitive materials. He has previously served as a senior process engineer and process sales engineer at FECO, FEECO International, where he expanded product lines, including fluid bed technologies and rotary kiln calciner solutions. He has a patent for the combination of dryer cooler design, has a bachelor's degree in chemical engineering from Iowa State, and maintains professional memberships, including the American Institute of Chemical Engineers. With that, I would like to introduce Tim and Walt. Go ahead and take it, or Tim and Walter.
Thank you, Jim. Good afternoon, good morning, everyone. Thank you for being here today. I'm going to walk you through the agenda. So if you can go to the next slide, that would be very helpful, Katie. So I think today's area will focus in on what I'm going to call one word is fundamentals. We want to ensure that we provide you good clarity and rationale and data points to define biochar and its key terminology. So the reason why we mention this point in terms of being really important, everyone on this audience has maybe a similar but a different view of biochar, and that's okay. We want to kind of take a few steps back and define what biochar is. Also, we want to really dig a little deeper into the process, comparing pyrolysis versus other thermal pathways. Again, providing some clarity to a landscape that looks really, really robust and interesting, and it is from a commercial perspective. But we want to ensure that from a chemical engineering perspective, Walter is able to walk you through some of those fundamentals of pyrolysis and other thermal pathways. Again, defining some of the biochar types, quality metrics, and industry standards. The other piece that I really focus in on to a great deal in working with Mr. Hawkins is feedstock preparation, conditioning, and drying. You know, there's an old saying that says garbage in and garbage out. Well, we look at the same way with regards to thermal processing. The more work we do and you do prior to the drying process, the better the throughput and output for all concerned. I believe I just lost my agenda item there. So if you could bring that up again, Katie, because I'll close out then. Okay,
I
the
know we
last,
had some connection
and
issues
that's
earlier
okay.
this morning.
That's okay.
Um,
I think,
You might
the,
have
the
lost
last
your share screen, Katie.
Yeah, the last 2 points are really defining expectations. And I think this is really important for both sides of the dryer in terms of the operator, owner, engineer, but also defining what type of capacity and throughput relative to expectations that Walter will cover. And I think one thing that's so, so important is ensuring that we have a collective understanding of emission controls and ensuring that we're drying to temperatures that are reflective of and respectful towards emissions permitting standards for every different location. And in closing, I mentioned clarify carbon credit capture and sequestration concepts. We're going to step away from that one today, and we're going to focus more in on the thermal processing mechanics from a engineering and an operator perspective. But with that, I'd like to hand the meeting over to Mr. Walter Hawkins. And one of the things that I've always been impressed by in working with Mr. Hawkins is his practical knowledge and not necessarily textbook or empirical perspectives, but more from a operational perspective. So having said that, he's going to throw a number of different concepts at you. We're going to walk through a number of different slides, but please take the time to put your questions in the chat area because we want to spend the next 20 minutes or so walking through content, but then that last 20 minutes walking through questions and answers that you present to Mr. Hawkins during his presentation. So with that, honored to be here, and I'll hand the microphone over to Mr. Walter Hawkins. Thank you, Walter.
Yeah, thank you for the introduction, and thank you everyone for coming. I guess I'm going to start this by saying, boy, the organizations promoting biochar outreach are doing their job and doing it well. Because right now, today, the number of people talking about biochar is phenomenal. I see a great deal of it directly.
Mhm.
I also see some as a consultant for other companies. Now, having said that, biochar has been on my radar and the people I've been associated with for 20 years for sure. There's been a lot of talk.
Mhm.
Only now does it appear to really be kicking in. But let me say this. Um, the title of this slide is what is biochar. I can tell you from talking to 5-10 people a week that have a biochar project. Biochar is a lot of different things to a lot of different people. So I'm going to speak generally and then I'm going to speak more specifically.
Mhm.
Okay, what is biochar? Biochar is the graphitic carbon left. It's the fixed carbon left after a thermal decomposition of a hydrocarbon material.
Mhm.
For purposes of this discussion, 90% of what we're going to talk about is going to be woody based biomass, whether that's corn stover, uh,
Big ass.
industrial lumber, residuals, bagasse, whatever. Let's
Mhm.
talk about that. We can also talk about other things that people are talking about charring, but for most purposes, I think generic biochar is referred to as a biomass that's been thermally decomposed into fixed carbon.
Okay. Next slide, please.
Yep. Okay. So in the effort of making biochar, there's a number of different options. Many of these are up here. Um, Part of what I want to say here is there's very often where somebody will say, this is what I'm doing, but there's a little bit of other stuff going on as well. So we'll talk about that later. But for purposes of what my view, 9 times out of 10, what I'm going to recommend for biochar generation is going to be an indirectly heated kiln mechanism of some type. There's a number of designs out there,
Mhm.
but we're going to seal that vessel up and we're going to try to indirectly heat the solids in the absence of oxygen to a temperature 700-ish Celsius with a retention time. Now, I'm not going to get into particulars because I'm going to tell you how changing these things can alter the product. But let's just agree that that's it. Absence of oxygen, indirect heating, everything else.
Mhm.
Now, now there's also an option for direct fired char production, such as in a rotary kiln, and it
with
can be
weird
done,
things in my ear.
but that would have to be done in
Biochar.
a oxygen
Biochar.
depleted atmosphere.
How do you like your biochar in your garden?
Hey, Mark, sorry, can you go ahead and just mute yours, please?
Yeah, we have.
Oh, sorry about that. So another example would be, a rotary kiln, but instead of indirectly heated, it would be directly heated, but there can't be oxygen. So what that's called is substoic or oxygen depleted or rich combustion. Again, all these are possible, but you've got to look at what the overall objective is.
Okay.
The reason I tend to recommend indirect 9 times out of 10 is because now there's nothing in the products of gaseous decomposition that is diluted. If I were to use a substoic flame directly in it, then the gas would also contain those gases. So the cleanest indirect char and indirect gas product would be the indirect fired mechanism.
Okay.
Okay, so that's pyrolysis. You're trying to limit, or I'll say actually eliminate oxygen to every degree. Gasification is and I got to be careful. I don't want to get in trouble with any manufacturers of these other designs. But typically gasification is you're going to bring in a little water vapor at the elevated temperatures. You get a little Fischer-Tropsch going on, but you're probably going to let in some air to allow some direct combustion of the material. Fischer-Tropsch is the high temperature water shift reaction where high temperature water vapor can hit carbon and make CO and H2. Air curtain burner, I don't know that I'd call that pyrolysis. That's more direct combustion. Thermal oxidizer, that's a term that's not really around the pyrolysis generation.
Mhm.
That's around what you have to do with the gases coming off. You have to do something with the gases coming off pyrolysis. You can try to capture them, reconstitute them. You can do all kinds of things. But what you can't do is just venom the atmosphere. If you don't have any plan for it, you're going to thermally oxidize it. But another thing of that is that's not necessarily waste. That's heat that can be used for some other purpose. I did kind of allude to a merger of these technologies. And here's kind of the thing that I'm getting at. Even in a direct indirectly fired kiln, very good seals, try to eliminate all of oxygen. Nothing would stop me from one day saying, I'm going to turn up the draft and let a little bit of air in there. I'm still going to make char, but that little bit of air is now going to combust in the kiln or in the pyrolysis device. And sometimes a little air bleed and direct combustion, whether it's known or not known, comes into play.
Okay.
And I can usually see that on the amount of heat or power that I'm putting into the heating elements. I can always reduce it by increasing the draft, but that would decrease my char production.
Okay.
So fundamentally, what it comes down to is you have to look at the project and say, what are my objectives? So let's go to the next slide. Okay. And this alludes to something that Tim tied up or referred to earlier. One of the things in doing like a biochar operation,
Mm-hmm.
you have to have control of the feedstock. Pyrolysis is really not a good dryer. It's great at getting things hot, but it's not good at transferring a lower value BTUs to like dry product. And what I mean by that is if you've got a pyrolysis system, almost any design I've seen, if you've got, big variations in the moisture going into the machine, you're going to get different quality of product, different capacity of product. Why was it working great for 2 weeks and now it's half the capacity? First place I would look to is water.
Mm-hmm.
Water is the enemy. Now I'm going to back up a little bit and give you an absolute layman's description of what I'm talking about. If you're going to go camping with a bunch of Boy Scouts or something like that and send a bunch of kids into the woods to say, I want to start a bonfire, you're going to tell them to try to find dead wood because it's going to be drier. Burning green fuel can be done, but its heat yield is worse. Anytime there's water, it's the biggest derater for the energy value. And like I said, the pyrolysis, you have to make the water go away, then you get the temperatures up. But if you've got a lot of extra BTUs that you have to transfer to drying, you've just derated the pyrolysis feature. The slide on the right, we're starting to hear a lot of people talking about other forms of biosolids, whether they're from agriculture or wastewater. People are talking about it. We're talking about it. Let's not make that the fore, but all the implications are the same. But the material preparation is even bigger because the variations are bigger.
Good point.
But again, let's talk big picture on fires. I burn a lot of wood in my fireplace in the winter. I don't live at the North Pole, but I do live in Wisconsin. But I like watching fire. I like a lot about fire. Here's what I'm going to tell you. You put a bunch of logs in. First thing that's happening is they're drying out. Once they dry out, now they start to warm up because you can't heat something that's wet. It retards the heating. Once the water is gone, it starts to heat rapidly. Once it starts to heat, again, there is no absence of oxygen and there's plenty of oxygen. But the first 30 minutes of that bonfire you've got going in the fireplace, there is no fixed carbon being burned. You're burning the volatiles that come out of the wood as the wood is gassing off the solids. Now, if you didn't have a flame there and you didn't have oxygen, but you got it to the same heat, you would be driving off what you see in that fire unburnt for other purposes. That's one of the differences. Now, when you see that happening, that's big, vivid flames. Then after the flames are gone and you've got the bed of coals, you don't see big overt flame, but you get a nice warm fireplace glow. That's the fixed carbon now burning. When the open flames are, it's volatile. When it's the ambient glow, that's carbon. So a little delineation here is when you see the big flames, that's kind of what happens in the pyrolysis. Those gases are being separated.
Next slide, Walter.
Um, yeah. Let me finish up the whole fire thing. So once you get to that fixed carbon, if you would somehow throw in a bunch of water on that bed of coals in your fireplace, that is one way to get biochar. There's a whole lot of biochar being made in the third world right now for cooking and other purposes, where you just start stuff on fire and then you bury it. It's thousands of years old technology, and it works and it's simple. But again, get the idea. That is not the same grade of biochar that can be made in these sophisticated equipments. Okay, let's go to the next slide. Okay, so what's going to affect the grade of biochar being made? A lot of things are. I do see a variation from, one species to another, tree sources and everything else. But again, as far as the machines that make the char, moisture is the biggest thing. But then on the end product, ash content. Like as an example, hog fuel is something that some people are going to char. That's got higher ash than heartwood would. So ash content is one thing that will affect the charring. Contaminations, certainly. If somehow, some way things got in there, predominantly metals, they could be problematic. I'm not saying they are, but that's something that people look at. Carbon content and stability indicators, that kind of ties into the H to C ratios and things like that. The industry is trying to define how far something's been pyrolyzed. Another term would be how much is it volatilized. As an example, we wouldn't call it char, but we've done a fair amount of work in wood pellets. And then all of a sudden, another variation before char is torrefied wood. That is when you heat it up enough to drive off some molecular water in the cellulose molecule. Again, that's a different product, raises the BTUs. Then you go to char, and again, depending on how hot you cooked it and how long you cooked it, you could have a lot of hydrogen or very little hydrogen. What we're really saying here is how hard did you cook it and how much residual volatiles would be left. But that affects a lot of other things. When we look at products to make, there's any number of products that people envision. There's a number that we envision, but depending on what we're trying to make, how far we cook it may affect that. As one example, one of the things that you can do with biochar that you can't do with virgin wood, I won't say can't, but it's way easier to grind biochar really fine. And there's any number of uses for really fine biochar. But my point is, when you do that, you make a change. Chemically, it might be the same, but now we may have affected the value of the product tremendously if we made it with an end use where that matters. And again, happy to talk about some of those things individually, but there's any number of products that we can make. So basically, the time and temperature is going to kind of dictate the chemistry and some physical attributes of the product. But then, how fine is it? Do we grind it further? Do we coat it with something? All those things go into the value added, which I do think people have to talk about, because I think, in my opinion, char has much higher value when it's applied to a value added purpose than when it's just virgin char. Just an opinion. Okay, let's go to the next slide. And Tim, this is kind of to you. every
Yeah,
plant is going to do better if the feedstocks are lined up and everything's, always the same. Now, I know that's a perfect world and it may not exist, but boy, once you start making the same thing every day,
mhm.
now you start to have a business has less headaches. You can quantify the product better. You can refine the product better. The less interruptions or surprises on the feed end, expect less on the back end. I believe that's well addressed.
Yeah, I think so, Walter. My emphasis here is that I know you're on the thermal processing side, but for your thermal processing and pyrolysis to proceed to throughput rates and capacity thresholds, there's a lot of work that the operators and owners of the pyrolysis biochar plant need to employ and manage really, really closely. And that's really my only point there, Walter, is that the pre-dryer preparation of the material is mission critical. Thank you, sir.
Yep. All right, next slide. Okay. Anybody in the biochar sector, I want to make one thing perfectly clear. Dry stuff has a higher value than wet stuff. Wet stuff is not something I'm trying to tell you to stay away from, but I'm saying it would require a drier stage. I would never feed a pyrolysis machine for all those, you know, things we talked about earlier at 50% moisture. Not saying it can't be done. I'm saying whatever that device is that can take 50 would
Mhm.
produce a whole lot more at 10 or 12 or 7 than it would at 50. Wetter feedstocks are cheaper than drier feedstocks, but it has to go into the equation. So here you can see that there are some products such as biosolids that are going to be 70, 80% moisture. Doesn't mean that they're not good candidates to run. Just the math is such that if you can get drier stuff at the same price, it's less cost to operate. But again, there may be times that that's not a bad thing because maybe you get paid to take a wet biosolids filter cake and the cost of drying it is such that when you're done, the cost is not prohibitive. But the moisture will affect your cost of operation, um, and throughput and everything else. Um, I think that's about all I have for that slide. Oh, and one more thing about moisture. It should be obvious. If I start with a ton of wood chips that are 50% moisture, it's going to be 0.55 tons bone dry or, whatever. Um, Obviously, you get more out of a ton of dry than you get out of a ton of wet. Um, and here's a nice little table that shows you a whole lot of the temperatures, whole lot of the heat is in not in heating the solids, but in evaporating the water. Water is energy. It takes energy to make water go away.
Mhm.
Next slide. Okay, I consider normal pyrolysis in the technologies that I have used over the years, and just a shout out, FECO International makes a very good indirectly fired rotary kiln. But based on the work I've done with FECO, on 1 ton of dried biomass, when we pyrolyze, we will yield about 500 pounds of char, 1,500 pounds of pyrolysis gas. And again, we've talked about it before. That's one of the reasons I want dry feedstock going in, because now my gas is more valuable. It has a higher BTU value. If I want to burn it and make energy, if I want to burn it in a boiler and make steam, if I want to burn it to dry other feedstocks, whatever I might want to do for heat, the pyrolysis gas gets better if the drier feedstock goes in. Plain and simple. To me, based on what I'm describing, typically pyrolysis to me has been 650 to 750 C, retention times 15 minutes on the short end, 30 to 40 minutes on the upper end. And again, those will affect the H to C numbers on which route we go. But also we've seen differences in porosity, in iodine number, in its ability to carry other chemicals, its absorption, its
Mhm.
its conversion to activated carbon, any number of things, including its grindability. So depending on how sexy we want a product to be, that'll come into the equation. If it's just making product that's good enough, that's one thing. Now, one call I had earlier this week was for low volatile char. I never heard that term, but that was supposedly where you take a biomass feedstock, you don't go all the way to char, you drive off enough of the volatiles, you keep some of the hotter volatiles, but you try to go to a more volatile coal grade to replace coal feed in a power plant. Don't know if that's ever going to turn into anything, but my point is, I cannot reiterate enough. There's a lot of things that people are calling char that are not necessarily, my description of char.
Sure.
Okay, next slide. We talked about how nobody could make char and just let the pyrolysis gas flare.
Mhm.
You'd have to do something with it. Ultimately, there's no getting away from it. You either got to try to condense as much as you can out of it to recover some form of an oil, which again, I've got feelings on. It's a little more complicated than I think most people are making out. But whatever you do, either you're going to drop out the oils by condensation, but you're
Mhm.
always going to have some non-condensable hydrocarbons in the exhaust, and nobody's going to let you just vent those to the atmosphere. Maybe you could be in the middle of nowhere and get away with it for a while, but it's not the letter of the law. That would have to be flared in a thermal oxidizer. Um, I mean, I'm open to other ideas, but I can't think of another one. It's a thermal oxidizer, at least on the VOCs, the non-condensables, and then also any particulate that may be in that gas stream will have to be separated, and that's usually a cyclone in a baghouse.
Mhm.
Now, one of the things is a lot of people want to do the filtration hot, and I would too. But again, there's people that say they can do it. I've never had any luck with it. There's technical challenges to do it. It's a lot harder than people might think. Um, next slide. Okay, soil amendments. What is biochar? If I was going to say what is the most generic explanation, there's a lot of people talking about biochar as a soil amendment to agriculture to make farms better. I'm very much on board with that. I think that's a great thing. I will say this, though. I'm not sure I understand what the economics of that are. I'm sure they can work for some people. But again, my only point would be if I'm going to make char as a soil amendment because it's going to be in the soil doing something, I'm
Mhm.
all for that. But if I could dope it with some organic fertilizer content or beneficial bacteria or something else, just think about it. Because one of the things about char that I think not enough people realize is you can load it with a lot of liquid. Okay, water, stormwater filtration media, definitely there's a place for that. Same with industrial reduction. Well, industrial reductants, that's a different thing. But I will say another thing that I consider biochar to be is a
Mm.
poor man's activated carbon. What do I mean by that? A really good industrial grade of activated carbon for cleaning water or decolorizing a hydrocarbon or whatever it might be. that's going to be a very, very thorough, you know exactly what you have. But is there a place for biochar, which is, it does have an iodine number and it does have a scrubbing feature? Is there a low grade activated carbon place for biochar? I believe it does. I call it poor man's activated carbon. And by the way, you can make full blown activated carbon from biochar, but it's another step. But you'll get part of the way there by only charring. So the lesser applications of, trying to clean up water or something like that involving biochar, I very much see that as a place. Industrial reductants, there is developing a very visible market for converting biochar to be a PET or a met coke replacement for making steel and other metallurgies. That is a thing. And it continues to grow. Concrete and asphalt additives, there's been a lot of talk about char as an additive there. And one of the things that I think we talk about more than a lot of the char people was the last item on that slide. And we lost that slide, but was around the energy side. So remember what I said, for every ton of dried biomass you pyrolysize, you'll make about 500 pounds of char, at least the char that I'm describing, no volatile char, very low volatile char, and 1,500 pounds of pyrolysis gas. That pyrolysis gas has a BTU value of 5 to 7,000 BTUs per pound, depending on how dry it is and all those things and what the source was. But you put that together, and on that one ton pyrolysis unit, that's got an, it's just shy of 10 million BTUs an hour. That can convert to about a megawatt of electricity or 10 millions of BTUs, which is, that offsets a lot of natural gas. So one of the things I'll always say is don't forget the exothermic side or the waste heat side of pyrolysis. If you're talking char, you've got to find a use for the energy. And like I said, it can be a lot of things, and we're happy to talk to anybody. And sometimes it's heating the kiln, but I would say let's take a good look at that, because in my opinion, sometimes there's a better use for it than that. Next slide.
I think that might be the last one, Walter.
Oh, okay. I guess that makes me finish a little bit early, but gives us more time for any follow-ups or questions. But I guess that's my summary, is biochar cannot really be viewed as a one product business. There's heat effects that have to be taken into account, and I see a lot of people that are just looking at the gas side or the solid side, and you've got to compare both.
Katie, were there any questions posed in the chat that Walter and I can
I think
address?
Katie might have lost. That's why we lost the screen share, and I was trying to hop in. But anyway, I apologize for that confusion in the background. I do have questions, and since we had them there. First of all, Marshall Mermel says, what is the largest pyrolysis system you have run in terms of the amount of biomass per day in 24 hours?
In 24 hours, 480 metric tons a day.
It's pretty good size.
Well,
We have a
but let me define that. That's the dried biomass going in to be converted, not the yield.
fantastic. Jim White asks, is there an issue with silane, SILANE, production plugging up the exhaust or heat exchanger tubes when pyrolyzing wheat straw or corn stover?
I have got to plead completely dumb to this one. I'm not sure.
And I believe, Marshall, did you have an answer on that one?
I think he's on.
Yeah,
mute.
sorry about that. I was muted. Yeah, it depends. I'm kind of interested in that 480 metric tons a day.
Mhm.
I've been in this business for over 20 years, and I have never, unless you're talking about the pyrolysis systems that are in Newark for SMR facility, I've never seen anything as large as that. We have systems that are 120 metric tons a day, and that's dumbed down. But most pyrolysis for biochar aren't processing that amount. So I'd like to know who's doing that and where we can get that. The second thing is the silane it's like what Walter was talking about. It's a factor of a lot of variables, and he is absolutely correct in that sense that it depends on what system you're using, what the temperature, what the moisture content, what the residence time. I mean, we've done this for 20 years. Biochar for soil amendment, we've been doing it for 10 years. It's not an experiment. We also do it for other purposes. And there's a book that I can show you. It's called Burn by Using Fire to Cool the Earth by Albert Bates and Kathleen Draper. That's a third-party verification that there's 100,000 markets. I, as the co-chair of Working Group 3 for the EU cost action on biochar, there are 500,000 markets. That doesn't mean they're all adopted and they're all ready to go. But all these technical aspects that Walter is addressing are absolutely correct. It's a complex topic. My analogy, it's like you don't go to a surgeon and say, um, which scope do you use, and then determine that's who's going to do the triple bypass on your father or mother. You do it based upon their results and not the tools. To us, biochar is a tool. Pyrolysis is a tool. They're important tools. Just like for a surgeon, he needs a scope or he needs scalpels and he needs anesthesiologists. But it's a team effort, and I think what Walter is expressing here in today's session is very valuable. I think what you're doing is he's sharing with everybody here that is not involved in this for a long time that it's a complex topic and you need people like Walter to help you get to the process of what you're trying to achieve. But you always have to ask the right question. And the right question is, what do we need to know to succeed? For that, you need to know what your end game is. And as Walter pointed out, there's different end games with pyrolysis.
Yep.
And so you're not, if pyrolysis was invented 80 years ago for chemical processing. Like if you landed in Newark and I took you down to Philadelphia, on the left-hand side, you see all these oil tanks. And on the
Yep.
right-hand side, you see what you think is a refinery. It's not. That's an SMR facility, one of the largest pyrolysis systems in the world. It's as big as Newark Airport, if not bigger. So they're different sizes. Most people have scaled up from small systems. And so I think Walter is giving us valuable information that tells you it's a complex topic and that you need to know what you're doing. This is like, you wouldn't want a neurosurgeon doing heart surgery or vice versa. So you need to know what you're doing. You need the people. And I think Walter is expressing a very valuable service to everybody on this conference.
Marshall, thank you for that. And not just the personal kindness you showed, but I love what you're describing. You come from that background, so you completely agree with my. If you're just looking at it as char, there's so many things here. So let's get back to the fundamental question. Am I worried about selene or anything else plugging up ducts and chutes and everything else? And I've got an answer for that, and that answer is hell yes. And I don't even I think the selene, no, but I can tell you this. If I pyrolyze a bunch of biomass to 1600 Fahrenheit, I am volatilizing some big hydrocarbons, which don't want to be gases on a duct that's 800 degrees and it's going to plug. So the answer to the question is when I drive off that gas, I'm going to insulate the hell out of any ductwork that's carrying that gas anywhere. I want that gas to stay hot. And if
Mhm.
it's going to drop in temperature, it is a massive, massive maintenance and operational headache. What do I mean by that? The duct is going to start condensing this heavy oil on it. Then you're going to have an emergency shutdown. Then it's going to turn into a brick. Then your 12-inch duct is 4 inches. And then something happens and you send a spark and now you just lit off 800 pounds of fuel in a duct. Do I have to go on? I don't think so. You've got to keep that duct. You've got to have a plan for these gases.
That is a
And
great
you also
point.
have to have the plan for using the gases. We use the gas. We have multiple technologies, not just pyrolysis,
Mhm.
that allow us to take the thermal energy and use that for heating and cooling. Also, drying up the feedstock, as Walter
Mhm.
expressed in his early part of this presentation. We also have what's called the Zajac engine that takes pyrogas in Europe, or we call it syngas, synthetic gas here in the United States, and converting that into electricity. One of our systems off of 120 metric tons, we can gang up 5 Zajac engines. Each Zajac engine processes 2.5 megawatts of power. So that's a lot of energy. So if you're in Africa and you're off the grid, that can develop a lot of power to people that are local. So there's a lot of opportunities here. And I think what Walter's expressing
Mhm.
here is the exact point that you need to become educated about what's going on. And I think Walter is expressing that very clearly.
Now, Marshall, let me jump on that and kind of ride your coattails because you're addressing the energy side. I'll be honest with you, I like the energy side of pyrolysis as much or more than the carbon side. Because here
Mhm.
is a couple things I'm going to say. Marshall, I'm not guessing your age, but you and I are, there's younger people on this call than we are. I remember when I was a kid, my grandfather asked him where he worked. He worked for Northern Illinois Gas. And then he would say, well, it wasn't Northern Illinois Gas when I was there. It was Chicago Battery and Light or something like that. Here's my point. Natural gases in houses, people don't realize how new that was. If you went back to 1910, New York, Chicago, Cincinnati, they somewhere that city had an pyrolysis project, either treating coal or wood. They were making their own town gas, producer gas, whatever. Before there was natural gas, municipalities were pyrolysizing to heat street lamps. Now, the other side of the energy side is, I'm kind of agnostic on my opinion of all the green stuff. Of course, I think we should strive to be better and everything else. But one of the things that I've heard on the environmental side is we got to stop digging up carbon. Okay, if you have a tree that's going to die and it's going to decompose into CO2 in 20 years, that's exactly what they're talking about. If that tree is just going to be left to decompose in a high forestry area, if you could pyrolyze it, make char, sequester some of the carbon, make the kilowatts, megawatts like you're talking about, Marshall, isn't that arguably greener than burning natural gas? And a gas, nat, natural gas is always going to be cheaper. You can drill a hole in the ground and do it, but if there's a means to not do that, what I'm saying is biomass. The industrial revolution started on wood and then migrated to coal. This biomass powered industrial revolution can still be done, but
It,
that's
it
where
is
I'm
being
saying
done. You're right. Walter, you're absolutely right. I
it,
totally
it,
agree with you.
and all I'm saying is anybody that's talking pyrolysis that isn't acknowledging the heat side, whether it's to do an endothermic process completely unrelated to the product, to make aluminum, whatever it is, to make kilowatts, it's just that there's a lot of BTUs. Now, Marshall, you would ask the question, who could do a 500 ton a day capacity? I'm talking about Fecal, who I'm a consultant to. We had an order for a big pet coke or metallurgical coke project I
Mhm.
think you probably know who it is. I don't want to say who it is.
Doesn't matter. Yeah.
We ended up anyhow. We can do 20 ton an hour indirect kilns, and there's about 2 or 3 other guys that can too.
Yeah, and I think that's a different form of pyrolysis than other types. I've been in this a long time. And I think what you're bringing out is that there's different types of levels of technology. An example is we have on this call today, Kelpie Wilson, who has her systems that are phenomenal, and they're perfect to be, let's say, in a forest where it's hard to get your equipment in there. And I'm a supporter of hers, but we also have large systems. We have large scale systems that process. And so I think it's like you're pointing out, Walter, you really need to know what is your end goal? What are you trying to do? It again, my analogy is a medical analogy. And the same thing with biochar. A lot of people wanted to use biochar as a soil amendment, and they would put it in the soil, and it would work great if it had a high carbon content and an HC ratio that was appropriate. But after 5 years, it would leach out all the nutrients out of the ground. So it's got to be formulated. It's like a drug, it's like a pharmaceutical. So each application has its different purpose. Back in 2015, I did circular mining in Spain, where we took a depleted mine and used biochar to clean up the surface area and at the same and the mine and extract the metals from the tailings and put that into special and sell it on the London Metal Exchange and still make money and at the same time plant a forest there. Now, in 2023 and 2025, there was a huge climate problem in the Iberian Peninsula. The ground was 50 degrees centigrade. You can't plant anything at 50 degrees centigrade. So I called up the university where I participated in that and I said, what's happening with our forest? They said, the forest is fine, 20 degrees centigrade, because they constantly uh, use a formulated biochar for the soil. And you have to know the soil biome. You need to know what you're doing. Again, it's a complex topic. And I think, Walter, your point that it's complex is really, really important. Thank you.
Well,
Just in
thank you.
interest in time here, we do have
Yeah.
to move on. We've been 10 minutes on this one, and we've got several other questions to come up. Jim White has been very patiently in the corner here with his hand up, but I'd like to give him a chance to talk here real quick.
Sure.
Yeah, thank you. Hey, Jim, I just want to compliment you on this whole effort and what you're leading the country on this effort and how you're bringing and yeah, so what you're doing is amazing. The one thing that's underappreciated is the fact that we've seen this, we use pyrolysis to generate electricity. As a fellow electric utility, I work for the electric utility here in Central Washington. But they've seen this where they're pyrolyzing peach pits and all kinds of wood products and everything else. That being able to generate electricity and remove carbon from the atmosphere, creating a carbon negative process, is fundamentally different than just putting it aside and being carbon negative, carbon neutral. Literally, the more energy you consume from this process, the more carbon you're taking out of the atmosphere. People will pay extraordinarily more for power to know, like, for instance, if you're using it to charge a bank of batteries for electric vehicle charging, people will go out of their way to drive and pay 50 cents a kilowatt hour for electricity that's carbon negative. You're not just going on a trip and it's carbon neutral. The more you travel, the more you use, the more carbon you're taking out of the atmosphere. That is unheard of anywhere else. And so it's an value added product that you certainly need to keep in mind if you can use this for power generation. The silane gas I just wanted to bring that up because it is an issue for the high silicon content fuels. So if you're using wheat straw, if you're using corn stoke, if you're using grass, those tend to produce, they can be handled. But once that gas, the silicon, the silane is removed, you can then burn that gas in a gas turbine to produce electricity, or even a spark ignition engine to produce electricity. So just, again, compliment you for bringing this up, trying the product. We have a local product that we're looking to produce to using yard waste and other things, removing the heat, the moisture from that, and then pyrolyzing to produce carbon. So just keep going. compliments to everyone here. Keep this going. We're on to something. We just need to get the word out and take it to the rest of the world and make them aware of it. Thank you.
Jim, thank you for that. I really enjoyed everything you said, and I agree with you. I have not been as bold as you are to say carbon negative technology, but it really is. And we're working very hard to promote a couple projects. But what we're saying is everything you said, but if you manage the heat cycles right, and we got a couple tricks under our sleeves that we can even improve on any number you've ever seen. But yes, there's a way to make the power that the world is going to need in 3 years while burying carbon. And that's something that people should get excited about.
Right. And just keep in mind that the power that's generated does not have to be sold at market rate. It can be sold at many times the market rate, multiples of that. It's worth that much more. Thank you.
Interesting. Yeah, I'd like to learn a little bit more about that, Jim, at some point, but I want to be respectful of Jim to Katie and your time. So go ahead, Jim.
And I do have this is hopefully time for one more question here. Apologies, great discussions. But now I had something pop up right on top of it. So Stephanie, our own Stephanie Santel, says she agrees with Walter's points on standards and quality control accounting. But there's a lot of conversation going on in the biochar work community and about the need for the standards. In your opinion, who is the best entity to develop, maintain, and enforce those standards?
Well, this is interesting. I'm trying to, I want to say this the right way and not offend anyone. But here's what I mean by that. I've done work with the biggest chemical companies in the world, and I've done work with little farmers who, wanted to handle the waste. I've done the full spectrum. So in answer to your question, ultimately it's the customer that is going to dictate the standards. Now, what I mean by that is if it's a big chemical company making a product out of the fixed carbon that comes off a char, they are going to be very, very meticulous in everything that we talked about on feed preparation and quality sorting and particle size and density. They're going to have requirements. But every time you find a bag with a company's name on it and it's a fixed carbon price, that stuff, if it's always the same, that's going to be the product. And that's going to be worth, if it's in a bag with a chemical company name, it's not, $50 a pound, or $50 a ton. It's, $1,000 a ton. But the same fundamental stuff that's going to vary in H to C ratio, ash content, whatever, from a farm or like just say an agricultural guy producing it, but for the purposes of a soil amendment, that's going to be fine, but that's going to be a wider degree on product quality. The more precise the product quality, the higher the value. And ultimately, I think there's going to be markets for guys just saying, give me 3 tons of stuff for my field. And then there's going to be guys saying, oh no, I need exactly this H to C ratio and I need this set of standards. So I don't ultimately know the answer, but I think there's probably going to be some cheap and dirty markets and some highly precise markets.
I just want to say along that line at the USBI, this disclaimer, I'm a board member there, but USBI recently in November did publish the ANSI North American standards, and this is for testing methods to harmonize the testing methods across here. European Biochar Certificate and International Biochar Initiative had their own standards and certificates. The EBC is a German-based, DINS-based. But IBI was a great place to start for setting those standards, but the methods were all over the board. So now at least we have a consistent standard third party or independent certification body or standards body to say that this is how you test that. And the discussion at the larger level is the customer will define a lot of those requirements, but at least now we'll have an even way of comparing and opening up the number of labs to do the analysis. And Graham, you mentioned about the ANSI number. I know it was the S688 committee, I believe it was. But if you go to the USBI website, they do have it there. So, but it's a great way. This is fantastic here today, but I wanted to hand it off to Tim. I apologize. There's more questions out here. We had a great time, but in the interest of time, I'll let you take it here.
Sure. Well, thank you, everyone. Obviously, a subject that is broad and deep, and I think requires probably more analysis and/or perhaps another webinar, Katie and Jim, at some point, so we can dig a little deeper. But I think we did definitely scratch the surface of, I think, what I call the fundamentals of biochar. I think we created some good dialogue, but now I think we need to take it to that next step. So I think two things can happen. One, I'll leave the kind of the next webinar, so to speak, topics to Jim and to Katie. But I think in the interim, you can reach me and I can work with Walter in kind of furthering these conversations and dialogue. So I think my email is in the chat, or then Katie can also, and Jim can provide post webinar. But I think we need now to move the ball forward. Now we need to continue to move the momentum forward. And again, providing some of those, what I call the fundamentals to your team and to your audience. But in closing, thank you for the opportunity. Mr. Hawkins, thank you for your practical experience and know-how. And I'll hand it back to Jim and Katie.
Well, this has been fantastic. Really great to see the engaged audience. The winner today is Brazil, for the furthest one that advertised for being here. So we welcome Alfonso, and great to have you on board here. But want to thank these fine gentlemen so much. Make sure you follow up with them. Thank you for attending, and we are recording this. This will be available on the website in probably about 2 weeks, Katie.
Yeah, probably next week.
Probably next week we'll have it available for further review. Great to see some familiar faces and great to see new ones. Please feel to reach us out. MNBI is a membership-driven organization. Please go out, check out our website. And if you're interested in participating in MNBI, even if outside of Minnesota, please feel free to join our organization and be part of the process. So we appreciate it. And with that said, hope next month, third Friday, we're just settling up. Katie and I are just settling up with the next round of presenters, and I just don't want to get until we get it locked in, but we have some good ones next month, hopefully on brownfields and on biosolids the following month. So we got some great topics coming up. Thank you very much for being here. Please reach out to us. Great to see you all, and have a wonderful weekend. And I hope to see you next month on Char Talk. Thank you.
Thank you, Jim.
everyone.
Thank you,
Thanks
Katie.
all.
Bye now.
Bye.
Bye.
Bye-bye.